Hey guys, this is Jordan with the practice set, and today we're going to do a problem involving cylinders and quadric surfaces, and let's just jump into it. Okay, so in this problem we have to describe the surface and find the foci and vertices of the given function. And the function that's given is y squared over 2 plus z squared over 8 is equal to 8. So the first step in solving this problem, and any problem where you're given a function that describes a quadric surface, is you want to simplify it as much as possible. And the way we do that is by setting it equal to 1, which is done by dividing it by 8. That gives us the function right here. Y squared over 16 plus z squared over 64 is equal to 1. So the first part of this problem asks us to describe the function, or describe the surface. So the first thing that we should do in describing this surface is notice that this function is an ellipse. As we can see right here, this is why we must know our quadric surfaces, guys. This is something where you should look at it and immediately say, all right, this is an ellipse. As we can see by the form here, y squared over b squared plus z squared over a squared is equal to 1. Normally, the a and b would be flipped, but the reason that we wrote it this way was because we were keeping a as the larger number, because we're going to be subtracting that later, but we're going to get to that. So we see that this is an ellipse. Then the next thing that we need to notice is that there's no x variable. We have y and z, but there's no x. So this means that this stretches infinitely in both the positive and negative x direction. And when that happens, we get a cylinder. So if we combine those two things, the ellipse in the two-dimensional plane and then the cylindrical portion of the 3D plane, we see that we get an elliptic cylinder, and that is how we answer the first portion of the question. To describe this function right here, it is an elliptic cylinder. Now what we do is we have to calculate the foci and the vertices, which is actually relatively easy, because for ellipses and for most of these quadric and for all these quadric functions surfaces, we have formulas for how to find these things. So in order to find the ellipse, the foci of the ellipse, we use this formula right here. The foci are located at 0, 0, plus or minus c. And that variable can change. It's always on the longest side of the ellipse, and that is why we were focusing on the 64 in the bottom right here. This plus or minus c can be in the x, the y, or the z coordinate. It's always on whichever side is the longest, and in this case, it's the z, so that's why the c is in the z. The plus or minus c is in the z coordinate. So in order to find c squared is equal to a squared plus b squared. A squared will always be the larger of the two numbers. So a squared is 64, b squared is 16. C squared is the difference between them, and we take the square root to get c is equal to 6.93, which means that the foci of this elliptic cylinder, or of the ellipse in the two-dimensional space, is plus or minus 6.93 in the z direction. Alright, so that makes it a lot easier to picture in your mind an ellipse where it stretches mostly in the z direction of the elliptical part, and the foci are at 6.93. Then what we have to do, the other portion of the problem, is we have to find the vertices, which is another thing that is given to us at 0, 0, plus or minus a. Once again, just like for the foci, the plus or minus a can be in the x, y, or z coordinate, but it's just always the longest side of the ellipse. And in this case, because of the 64 in the denominator, that is the z coordinate. So we don't even need to solve anything really, except for taking the square root of a. It involves even less work. The a in this case is 64, so the vertices are plus or minus 8. So we see that our foci is 0, 0, plus or minus 6.93. Our vertices are 0, 0, plus or minus 8, and our shape is an elliptic cylinder. So I hope you guys got a lot from this problem. If you want to do more problems like this and see more problems explained out, check the rest of our YouTube channel out. And then please check out our website, thepracticeset.com. The link is in the description. We are an upper-level STEM practice problem database, upper level being upper-level high school and college STEM classes. We take your problems, solve them out step by step, and explain the rationale behind them so that you really can understand what's going on in these problems that are pretty high concept. So we really hope that we can see you there, and we'll be giving you guys more problems. All right, bye-bye.